Hello, in this video, I'll be solving questions on IGCSE Chemical reactions. My first question is from May-June 2024, paper 4-1, question 4. Hydrogen iodide thermally decomposes into iodine and hydrogen. The reaction is reversible. 2Hi gas giving I2 gas plus H2 gas. The hydrogen iodide gas is colorless, the iodine gas is purple, and the hydrogen gas is colorless. Figure 4.1 shows a gas range containing a mixture of hydrogen iodide, iodine, and hydrogen gases. The gas range is sealed and the mixture is heated to 300 degrees Celsius. The mixture of gases reaches equilibrium and is purple. This is a diagram of the gas range containing the mixture of gases. A. State what is meant by the term equilibrium. When a reaction is in equilibrium, first of all, the rate at which the reactants react to give products, it is the same rate that the product will be converted back to the reactants. And also, concentration of the reactants and the product do not change. So you have to say that the rate of forward reaction equals the rate of backward reaction. And also, the concentration of reactant and product remain constant. B. The pressure of the mixture is increased. All other conditions stay the same. The position of equilibrium does not change. The color of the gaseous mixture turns darker purple. The temperature remains constant. I. Explain why the position of equilibrium does not change. So the position of equilibrium for this reaction does not change when the pressure was increased, because an increase in pressure shifts the equilibrium position in the direction where there are fewer moles of gas, so that the equilibrium can shift to the opposite direction in order to reverse the change of increase in pressure according to Le Chatelier's principle. But when we look at this reaction, there are 2 moles of gas particles at the reactant side, and also there are 2 moles of gas at the product side. So it means that the number of molecules of gas at both sides of the reaction is the same. So there is no way the equilibrium is going to shift to either side of the equation. So we have to say that there are equal moles of gas on both sides of the equation, and it is the reason why the equilibrium does not shift to any side of the equation. II. Suggest why the color of the mixture of gases turns darker purple. So we were told that when the pressure of the mixture was increased, the gas mixture turns darker purple, and we are supposed to explain why the gas mixture turns darker purple. Now, when you increase pressure, you realize that all the gas molecules are forced together. So we saw that it is the iodine gas which is purple in color. And once pressure has been increased, the molecules of iodine are forced to come closer together. And so because of that, you are going to see the purple color become more darker in the reaction mixture. So we have to say that iodine molecules are forced together. C. The temperature of the mixture of gases is decreased. All other conditions stay the same. The mixture of gases turns lighter purple. State what can be deduced about the forward reaction from this information. Notice that in this question, the temperature of the reaction mixture was decreased. And in equilibrium reactions, when the temperature of a reaction mixture is decreased, the equilibrium shifts to the exothermic side of the reaction. And in this question, we're also told that as the temperature was decreased, the mixture became lighter purple, which means that this reaction is not favoring the iodine side, because it was iodine that is purple in this reaction mixture. So it is against the iodine side. If you look at the reaction equation, the iodine is at the product side. And if as temperature was decreased, the reaction is against the iodine side, it means that the equilibrium is shifting to the left side. And so it means that the left side of the reaction is exothermic. If that is the case, then it means that the forward reaction is endothermic. So the forward reaction of this equilibrium reaction is endothermic. The second question is from May June 2024, paper 4-2. Question 3. The symbol equation for the industrial production of ammonia is shown. The equation is N2 gas plus 3H2 gas giving 2NH3 gas. The enthalpy change of reaction is negative 90 kilojoules per mole. Name this industrial process. So the process used to produce ammonia is called the Haber process. B. State the meaning of delta H. This means change and the H means enthalpy. So anytime you see this, it means enthalpy change. C. State the typical conditions and name the catalyst used in the industrial production of ammonia. So for temperature, the compromised temperature used in the Haber process is 450 degrees Celsius. The compromised pressure used in the Haber process is 200 atm, or in terms of kilopascals, if you convert it, you get 20,000 kilopascals, because 1 atm is equal to 100 kilopascals. And the catalyst used in the Haber process is iron. D. State two methods of increasing the rate of this reaction. So in this reaction, we are already using iron as our catalyst. So it means that you have to, if we need to increase the rate of the reaction, then we can work on the temperature and the pressure. So you know that an increase in temperature increases the rate of a reaction. So we can increase temperature. And also we can increase the pressure as well. Because once we increase the pressure, the reactants are forced together, and that is going to increase the collision, and hence the rate of the reaction is going to increase. So increase pressure in this reaction. The next question is from May June 2024, paper 4-3. Question 4. Dinitrogen tetroxide N2O4 decomposes into nitrogen dioxide NO2. The reaction is reversible. The equation for this reaction is N2O4 gas giving 2NO2 gas. The dinitrogen tetroxide is a colorless gas, and the nitrogen dioxide is a brown gas. Figure 4.1 shows a gas range containing a mixture of dinitrogen tetroxide and nitrogen dioxide. The gas range is sealed. The mixture reaches equilibrium, and the color of the mixture of gases is a pale brown. This is a diagram of the gas range containing the two gases. A. Describe a reversible reaction at equilibrium in terms of the rate of the forward reaction and the rate of the reverse reaction. So for equilibrium reactions, the rate of forward reaction is equal to the rate of backward reaction. So you can just say they are equal. And the concentration of reactants and products. In equilibrium reaction, concentration of the reactant and product are always constant. So we just have to write constants. B. The pressure of the mixture is increased. All other conditions stay the same. The mixture immediately turns darker brown before the position of equilibrium changes. Explain in terms of particles why the mixture immediately turns darker brown. When the pressure of a reaction is increased, the particles in the reaction mixture are going to be forced together. And so the reason why the mixture turned darker brown immediately the reaction pressure was increased was because the NO2 gas particles, which is a brown gas, were forced together into a small volume of space. So we have to say that NO2 gas particles increased per unit volume as the pressure was increased. C. The mixture of the temperature of the mixture is increased. All other conditions stay the same. The mixture turns darker brown. State what can be deduced about the forward reaction from this information. So when the temperature of a reaction in the equilibrium is increased, the equilibrium shifts to the endothermic side. And we were told that as the temperature was increased, the mixture became darker brown, which means that the equilibrium was shifting to the product side, which is the NO2 side. So therefore, as the reaction is shifting to this side, it means that the product side is the endothermic side. So you have to say it is the endothermic side of the reaction. D. Sulfur is converted into sulfuric acid, H2SO4, by a series of reactions. Sulfur dioxide, SO2, and oxygen, O2, react to form sulfur trioxide, SO3. The reversible reaction reaches equilibrium. The reaction is 2SO2 gas plus O2 gas giving 2SO3 gas. I. Complete table 4.1 using only the words increases, decreases, or no change. So in table 4.1, you are supposed to comment on the rate of forward reaction if a catalyst is added. Now, a catalyst only increases the rate of both the forward and backward reaction of a reaction in equilibrium equally. So, catalyst increases the rate of forward reaction. An increase in pressure will force the reactants closer together, and so they are going to collide faster and therefore be converted to product. So, which means that increase in pressure will also increase the rate of the forward reaction. Now, for the effect of catalyst on the equilibrium yield of SO3, a catalyst only increases the rate of a reaction. It does not change the equilibrium position. So there is no way a catalyst is going to have an effect on the equilibrium yield of SO3. But for an increase in pressure, it will favor the side with fewer gas molecules, according to Le principle. And it says that when the pressure is increased, the equilibrium shifts to the side with fewer gas molecules so that the pressure can reduce again. So it means that as pressure is increasing, it is going to shift the equilibrium position to the right side. And so that will increase the yield of SO3. II. Deduce the oxidation number of sulfur in S. The oxidation number of a single atom is always 0. So in order to find the oxidation number of S, I'm going to underline S. So we add the oxidation number of all the atoms in this molecule together. So we don't know that of sulfur, and so we just write S plus the oxidation number of oxygen in most of its compounds is -2. So plus -2. But there are 3 oxygen atoms here. So we multiply this with 3. It must be equal to the charge on the SO3. And looking at SO3, there is no charge on it. So it means that we equate this to 0. So sulfur minus 6 is equal to 0. So if we move the minus 6 across the equal to sign, it means that sulfur is going to be plus 6 in SO3. Thank you for watching. See you again in the next tutorial. Please subscribe to this channel.